Today's video, cloud computing in the year 2020. A little bit tired today, kind of had a long day.
October 23rd, 2019. Google announces it has achieved the impossible goal of quantum supremacy. A machine more...
October what?
October 23rd, 2019. Google announces it has achieved the impossible goal of quantum supremacy. A machine more than 100 million times faster than your 16-inch MacBook. Only 1 month later, AWS releases quantum computing as a service in the cloud. If you're a software developer in today's world, there's a good chance your infrastructure is on the cloud, and very likely with a big provider like AWS, Azure, GCP, or IBM. 90% of companies are on the cloud, 60% of workloads run on the cloud, 30% of IT budgets are allocated to the cloud, generating hundreds of billions of dollars in revenue, and those numbers are only expected to increase in the coming years. In today's video, you'll learn exactly what cloud computing is, why companies are adopting it so rapidly, and what you need to know as a software developer. If you're new here, like and subscribe, and you can follow along with the full write-up on
but this is still interesting.
Cloud computing is a win-win, both for companies that provide the services and the companies that use them. The providers make tons of money. In fact, AWS makes up more than 13% of Amazon.
So AWS is by Amazon. Interesting. Damn, they got their hands on quantum computing, aka developing a software service for... I'm guessing this is basically a quantum computer, a satellite, which is like a quantum computer that gets launched into space, and then it provides cloud service for users here on Earth. And I believe AWS is it's owned by Jeff Bezos,
Amazon's total sales, and operates at a much higher profit margin than its retail business. But it's also a huge win for their customers. Instead of buying and managing its own hardware, a startup today has all the infrastructure it could possibly need right at its fingertips. The startup only pays for what it actually uses. It takes...
Cloud is about how you do computing, not where you do computing. Huh. So okay. So this quote is interesting by Paul Marty, CEO of MWware. Cloud is not how you do computing. Cloud is about how you do... Oh my god, guys, bear with me. I'm super tired right now. Cloud is about how you do computing, not where you do computing. Okay. So basically how you do computing, like... I'm assuming he's trying to say... basically cloud is like you could be anywhere around the world because it's cloud, it's in the space satellite. And so it's about how you do computing, like what you do with it, like saving videos. Even YouTube is a cloud service right now, like streaming YouTube videos. So you're basically streaming YouTube videos on your whatever device you use, phone, anything. It's a cloud service. All the videos that have ever been uploaded on YouTube is they are on a cloud lined up. Damn. How does Google keep store of all this data? How much do they spend on their servers, man, just to keep all these YouTube videos up? I imagine it might be a lot, but at the same time they do have a huge market, so I'm guessing they do make lots of profit, which is most likely an ad revenue. And let's just continue, guys. We're not gonna get done through this video if I keep interrupting, right?
No effort to scale things up or down, and you don't need to hire an IT guy to wire the thing up. I mean, imagine if I tried to build a server room here in Phoenix, Arizona. My air conditioning bill alone would likely far exceed whatever my AWS bill would be for the same set of resources. That's because they build these highly optimized cloud campuses next to rivers to optimize cooling, with state-of-the-art equipment that can guarantee uptimes of 99.99% and beyond. I like to think of cloud computing like a power plant. You don't care where or how that power is being generated, you just plug in your device and then pay the bill. In fact, we might as well just call that electricity as a service. Because as a developer, it's important to distinguish between the different categories of cloud services out there. The modern cloud can trace its roots back to 2006, when Amazon launched EC2 and S3. EC2 stands for Elastic Compute Cloud, and it's essentially a virtual computer with its own RAM and CPU, along with an operating system you can administer and an IP address for networking. When you spin up a server in the cloud, it's called a virtual machine, because you haven't actually allocated any specific piece of hardware. Rather, the cloud has virtualized a simulated environment for you that resembles a piece of hardware. There's a lot going on behind the scenes to make this possible that you don't really need to know, like how they use hypervisors on top of bare metal to handle CPU scheduling and memory allocation. The other big service launched by AWS back in 2006 was S3. which is basically a hard drive with a file system in the cloud where you can store things like images and videos. Things like storage buckets and virtual machines are known as infrastructure as a service. They're the low-level building blocks of the cloud, so it's up to the developer to manage and scale them. Once infrastructure became available, it created explosive growth in a new type of software as a service. A great case study is Dropbox. In the early days, the company didn't have the money to roll out its own infrastructure, so it uploaded its users' files to S3. So it didn't even really start out as a file storage company, it was more of a software company that helped people get their files uploaded to the cloud. And it just goes to show you that you can build a billion-dollar business by focusing primarily on the front-end user experience. So infrastructure as
Front-end user experience.
a service abstracts away hardware. It took no more than a couple of years to see cloud computing rise to another level, a platform as a service. When developing an application, developers have a lot more concerns than just hardware. You have to think about security and how to scale the workload, and how to put all the pieces together into a cohesive unit. That's what a platform as a service aims to do. Some famous examples include Elastic Beanstalk, Heroku, and Google App Engine. Let's imagine a developer has built an app with Ruby on Rails. In order to be used by people around the world, that app will need a database and a web server with a very specific configuration. The platform is designed to take care of the configuration part. In theory, the only thing the developer has to do is upload their code, and the cloud takes care of the provisioning of the database, provides security, and scales the traffic. So what we have here is a platform for creating software as a service. But we can still take things one step further. The cloud can also provide SDKs that bring the cloud directly into our front-end applications. And that means a developer might not need any back-end code at all, giving us a back-end as a service. The two big players in this space include Firebase from Google and Amplify from AWS. With just a few lines of JavaScript, anybody can create a real-time application with user authentication hooked up to a cloud database that's way more reliable than any back-end you would build from scratch. Sounds awesome, but it's not without its drawbacks.
Okay,
The more you rely on services offered by a given cloud, the more likely you are to experience vendor lock-in. The cloud can help you get your software
Vendor lock-in. That's a very fancy term.
off the ground, but once you become successful, like Dropbox, your opinion might start to change. In 2016, Dropbox started to move their customers' data off AWS to their own data centers, and cut at least $75 million from their operating expenses. In this case, it made sense to move off the cloud.
Oh, so Dropbox was using AWS, aka Amazon service, and
Dropbox started to move their customers' data off AWS to their own data centers, and cut at least $75 million from their.
I was waiting for that green number to pop up. So basically, Dropbox was using AWS as a. They were using. Wow, interesting. They were using Amazon's AWS cloud service. And then later, like vendor lock-in, aka like when you use a company's service, like in the form of a cloud, you're likely to be vendor lock-in, like he said, vendor lock-in, like hooked, like basically hooked on their terms and services, because they're providing this value to you. And so what Dropbox did here was freaking change from AWS, right? That's obviously owned by Amazon or Jeff Bezos. And get 75 million of its customers to go to its own servers, so they had to run their own servers, their own hardware servers to provide cloud services. But I'm pretty sure it was an expense they had to take, but a good one, so they wouldn't be vendor locked in, or hope I'm saying it right. Vendor locked in.
Operating expenses. In this case, it made sense to move off the cloud to on-premises. But they're actually not fully on-prem. They still use the cloud to handle about 10% of their file uploads, especially for edge cases and regions that their data centers don't cover. And that's what we call a hybrid
left
cloud.
headphone just
It generally
died.
refers to big enterprises that run a private cloud on their own data centers, but also combine it with services on the public cloud. And by public, I mean the cloud where you can just sign up with an email address and credit card and start doing stuff. You might also hear the term multi-cloud. This refers to a single architecture or application that combines services from multiple public clouds, usually to prevent things like vendor lock-in and optimize pricing. Now let's go ahead and jump into the cloud and take a look at some of its capabilities. We already talked a little bit about virtual machines and cloud storage buckets, but that's just the tip of the iceberg in today's world. AWS alone offers more than 150 different services and APIs. But one thing all these services share in common is a service level agreement, or SLA. This is a contract between you and the cloud provider. The provider generally guarantees a certain uptime and error rate for the service and will generally provide a financial credit or refund back to the client if it fails to meet those SLA requirements. On the other side of the coin, the client generally has a quota that they must stay within when using the service. Sometimes I like to say the cloud scales infinitely, but I don't mean
a constraint.
That to be taken literally. The quota tells you how far you can push the limits. When getting started with a cloud provider, a great place to start is with identity and access management. The opposite of who am I am. It's the front gate to your infrastructure, and you shouldn't just let anybody in. You can secure your services by attaching security policies to them. For example, you might have a storage bucket, and that policy controls who in the organization can actually access the files inside it. Now, if your organization has thousands of employees, it would be very cumbersome to manage policies for every single resource. That's where roles come in. They allow you to group permissions together into a unit that can be reused throughout the cloud. And you can assign roles outside of your account if you're working with consultants or some other third party. Now, in some cases, your machines might need to communicate with each other. For that, you can define resource-based policies or service accounts. This would allow a virtual machine, for example, to access a database somewhere else in your cloud. Now that we know a little bit about security, let's take a look at the backbone of the cloud, compute resources. On Google Cloud, we can create a virtual machine with Compute Engine. It will give you some options when you create this machine. The region represents the actual physical location of the data center. A region closer to your end users should be faster, but some companies must follow data residency regulations, which dictate where customer data can actually be stored. Now, each region is actually a campus with multiple isolated data centers. That means if you have a mission-critical workload, you can put it in the same region in multiple zones. If a meteor destroys one of those data centers, you'll still have a reliable service in that region. That gives you high availability and redundancy. Azure actually has the most data centers of all the clouds, and they have 2 secret government locations that we don't even know about. The next option is the machine type, which defines the amount of memory and CPU in this virtual machine.
Okay, this is all just...
The bigger they come, the more they cost. But the great thing about the cloud is that everything
this is just talking about
your build down to the second, and you can shut the instance off at any time.
Let's see.
From there, you need to determine the version can only be...
This is all management. Basically, the in-field look if you want to use cloud to manage employees or a company. If you're developing, if you're using cloud as a developer, but let's skip forward. We don't want to look at that. We just want to know about cloud computing, bruh.
World into your instance.
The title: Cloud Computing the Year 2020.
Egress is typically the one to watch out for because it can have an impact on your bill. Now remember, we're just talking about
I'm trying to watch cloud computing the year 2020. Like, want to know what's coming. You know, we don't want to know these 2 minutes right here talking about in depth how to use the Google Cloud data to manage employees, or if you're a developer. We just want to know about cloud computing and those satellites, not satellites, those cloud computer satellites, I believe they were at the beginning of the video, where he said that, was it Google that developed they developed something that was super fast, something like that.
Simulated computer here. If we want to access the command line for that instance, we can do so directly in
more in-depth field stuff. Let's just skip this.
Load accordingly. When you distribute VMs like this, you also need to worry about load balancing. You don't want all of your traffic going to a single VM while the others are just sitting there idle. And that means today we can do pretty much anything we want in a serverless environment. There are still some other trade-offs, but generally speaking, it's the easiest, most cost-effective way to deploy back-end code that scales. And I think that's pretty much everything you need to know about the compute and cloud computing, at least until we have quantum computers in the cloud. Oh wait, I almost forgot. It's 2020, we have those things already. I'm going to go ahead and wrap things up there. If you learned something, please like and subscribe.
So in summary, basically cloud computing is it's a cloud service, and that I'm okay. Don't quote me on this because I might be wrong, you know. But cloud computing is basically cloud services, a cloud service or cloud services in the form of an absence of servers. So you don't need a huge server room with fans to cool down your server. So you can operate a cloud company, because a cloud service company, because now there's cloud computings which AWS, aka Amazon, has provides that service. You can just pay them to run your own cloud service company, whether it be Dropbox, another form of a Dropbox, or and Google has another cloud quantum computer in the air. I don't know what the hell where this is. I don't know if it's in a physical location that they have it, or as in the form of a satellite. But basically, those quantum computers, cloud quantum. Bear with me. Those cloud quantum computers do the job that a server will does the job in the absence of a server. Like, you don't need a server. You don't need to run a server. Um, you don't need to run a huge expensive server to provide cloud services to your customers. You can just use AWS or Google's, and I forgot what was the other provider. It was something called Fire something. Might have been. I'm not gonna say because I can't remember. But I know AWS and Google was mentioned in this video that they have quantum computing for cloud services. Yeah, that's it. So basically, you could run a cloud service business in the absence of a server. Like, you don't need an expensive server. Like, I'm guessing servers rely on because I've seen Linus Tech Tip videos, right? And I've seen their servers. It's basically like graphics cards. Like, they have like this little freaking what do you call that shit? Uh, like little cases, and they have like graphics cards and a bunch of a bunch of connectors, to and then they had fans cooling it, and it's like a basically a server, like a mini server, so they could run stuff. And I'm guessing that's what a server is, just having a lot of wherever it is, so you could run a cloud service. But now you can make a cloud service. You can make a cloud service company where you deliver a service based on a cloud without that server, with the help of AWS or Google, which they own quantum computing. Uh, but you're gonna be like this guy said right here. You're gonna be locked, some shit like that, locked, whatever. I'm tired, man. I had a long day today, and I'm kind of tired. I might redo this video again, like when I'm less tired. I'm kind of sleeper now. My head is sleeper now, and again, I'm not a developer. I'm not in any way or nothing. I just clicked on this video because I thought it was interesting. Cloud computing, the year 2020. It's like, oh, cloud computing, the year 2020 is something interesting. Let's click on it, and it was. All right, guys. Till next time.